Number 38, it says a car accelerates from rest at a constant rate of 2 meters per second for 5 seconds. What is the speed of the car at the end of the time, and how far does the car travel in this time? So in order to do this problem, what we're going to have to do is just list our variables first and draw a picture and then pick some equations. So for problem number 38, let's read that again and try to draw a picture. It says a car accelerates from at a constant rate of 2 meters per second. So I'm going to draw my little car, and we're going to say that the acceleration is 2 meters per second squared, and it says that it does that for a time of 5 seconds. And then it says what is the speed, which is the final velocity, okay? And then it says how much distance did it travel in that time, which is delta x. Well, right now we only have 2 things. Well, actually we have 3. It says that the car was at rest when it started. So whenever it says something was at rest when it started, we know that the initial velocity is 0 meters per second. Okay? So I have the initial velocity, the acceleration in time, and it wants the final velocity. Well, if we go in our textbook, there is some formulas that we could use, and I'm going to write all the formulas down. I know which one to use, but I'm going to write them all down and we're going to choose it. So on page 57, here are all the kinematic equations. So we have the average velocity is equal to the final velocity times the initial velocity over 2. We have that the final velocity is equal to the initial velocity plus acceleration times time. We have that the final position is equal to the initial position plus 1/2 times the final velocity plus the initial velocity times time. We have that the final position is equal to the initial position plus the initial velocity times time plus 1/2 acceleration times time squared. And then lastly we have the final velocity is equal to the initial velocity squared plus 2 times acceleration times x minus x naught. Okay? So what we're going to do is we're going to look at all of these equations and see which one will work. Well, I have acceleration. I have that. So this is a candidate, this is a candidate, and this is a candidate. So right off the bat, I could see very clearly that because this equation doesn't have any acceleration, I can kind of think of that as not being useful. The next thing I have is time. So since I know what the time is, I could possibly use this equation. I could possibly use this equation. This equation doesn't have time at all. Well, I don't know. We could check it off the list. Maybe not. I don't know. So let's just politely just put a little line through it. We might come back to it. I don't know. Now here's the thing though. I need to pick out an equation that will give me the final velocity. This equation does not have the final velocity. I have the initial velocity, right? I know what the initial velocity is, and this equation has the initial velocity in it, but nowhere in this equation does it say anything about a final velocity. And so since it doesn't say anything about a final velocity, I've got to disregard this. That one's no good to me. However, this one has an initial velocity, it has the acceleration, it has the time, and guess what? It has what I'm looking for, the final velocity, right? That's what I'm looking for, is the final velocity. So that's the equation that I would choose, right? So what I'm going to do is I'm just going to plug in the value. So I'm going to say that the final velocity is equal to the initial velocity plus the acceleration times time. Well, the initial velocity is 0 meters plus the acceleration times time, which is going to be 2 meters per second squared, times the time, which is 5 seconds. and it's really 5/1 seconds. So now what I'm going to do is 0 meters. I don't need to write that down. All right, that's gone. And 2 times 5 is 10, so I have 10. Now one of these seconds cancels with this second, so I have 10 meters per second. Right? And that's what velocity is supposed to be, is 10 meters per second. Wow. This is 10 meters per second. So now the next thing I need to do is find the displacement. Okay. So to find the displacement, I can pick any one of these 4 equations. I need to pick an equation though that has x equals x naught. Now I'm going to let you in on something. Mr. Adams always in his mind thinks to himself that delta x is equal to x minus x naught, because a lot of times they'll tell you what the travel, how far are you traveling. And so here, if I let the initial position of where the car is, in other words, if I let x naught equals 0 meters, then the final position is actually going to be equal to the displacement, which is a little weird, but that's okay. Why is that on my screen? Huh. Oh, that was weird. Okay, so probably what I'll do is I could use really any one of the 3. I'm going to choose the one that has the least amount of work to do. So I'm probably going to choose this one, right? So I'm going to say the final position is equal to the initial position plus 1/2 times the final velocity plus the initial velocity times the time. Okay, well this is 0. And my initial velocity is 0. So I'm stuck with x is equal to 1/2 times 10 meters per second, okay, times the time, which is 5 seconds. Okay, and notice that the seconds cancel out, boop, boop, and that's 1/2 of everything. So I have 1/2 of 10, which is 5, times 5. So it looks like it would be 25 meters, yeah? Let's see. Look in my handy dandy teacher book, and yep, that's the right answer. So what are we saying? We're saying that if a car starts from rest and accelerates at a constant rate of 2 meters per second squared and travels for 5 seconds, then after the 5 seconds, its final velocity will be 10 meters per second. That one's kind of an easy one. But then, because it is traveling from 0 to 10 meters per second in 5 seconds, it will have covered 25 meters in that 5 seconds. Cool.